This video is for lesson 4-1, Segments and Midpoints. The learning goals are to apply the segment addition postulate to find lengths of segments, and also use the definition of midpoint to find lengths of segments. In geometry, axioms, which are also called postulates, are statements that are accepted as true without proof in order to provide a starting point for deductive reasoning. Like the word point, line, and plane, this concept, distance along a line, is an undefined term. For example, the length of a line segment is the distance between its endpoints. If 2 points are no more than a foot apart, we can find that distance using an ordinary ruler, and we will do that in this class. Our rulers will have inches on one side and probably the metric system or centimeters on the other side. Here's an example drawing in the video of a segment from point A to point B, and if we wanted to measure the length from A to B, we could position 0 at A and then read off what number point B is located at, in this case exactly 5 inches. But you don't need to do that. You don't have to position a ruler starting with 0. You can start the ruler with any number you want to. So here's the same segment, but this time point A is starting at 2 and point B is at 7. We can still find the distance between 2 and 7. It's also going to be 5 inches as before. So the idea about using a ruler is that you are simply subtracting your ending value minus your starting value. It's nice if the starting value is 0, but that doesn't have to be the case. Number 1, determine the length of each segment in the book in centimeters. We're not going to take the time to put rulers down in the book and actually have you measure them. So here in the video, these are the results. Notice that when measuring in centimeters, I'm going out to 1 decimal place, which represents those millimeter marks on the ruler. Number 2, similar idea. This was just another opportunity to practice again using the ruler. Hopefully, though, you know how to use a ruler from years of being in school. Number 3, using your results from items 1 and 2, describe any patterns that you notice. So let me scroll back to number 2. In this drawing, there's a long segment from G to K. The letter H is kind of in between them. And when we measured from K to H, so this second piece here, it was 4.9. When we measured from H to G, so this first section, that was 5.7. And when measuring from G to K, the entire segment, that's 10.6. Please notice the connection of the number 4.9, 5.7, and 10.6. Do you see it? If you add together the two smaller sections, that equals the length of the entire thing. I hope that that intuitively sounds correct to you. And so here in purple, I've written that out. The length of the long segment is equal to the sum of the lengths of the two shorter segments. Question 4. Given that N is a point between endpoints M and P of line segment MP, describe how to determine the length of segment MP without measuring. If you're given the lengths of segment MN and segment NP. So this was a long sentence. Let's go back to the beginning. Given that N is a point between the endpoints M and P. So I have drawn a segment with endpoints M and P, and we're told that N is a point somewhere between them. It doesn't say exactly in the middle, so somewhere between them is point N. Describe how to determine the length of MP. So the length of MP, the entire segment. How could we find that length? Not by measuring, but if we were given the lengths of MN and we were given the length of NP. Well, that's that idea that was just expressed up above. If we add together those two shorter lengths, that's equal to the long length. And I've written that here in symbols. I want you to notice that MN without a bar on top means the length from NN, or for short, length MN. If there was a bar on top, that is segment MN. So they're certainly connected to each other, but one of them means the actual physical segment itself, whereas just two letters side by side is referring to the length or distance between M and N. Question 5. Use the segment addition postulate and the given information to complete each statement. Okay, segment addition postulate, that was one of the goals for this lesson. What is that? The segment addition postulate is this idea that we had written in purple. And in the next question, this idea that we had expressed in symbols, that you can add together two smaller lengths to equal to a longer length. That's the segment addition postulate. So let's tackle these questions. Question A, if B is between C and D, to help us do this question, let's draw what this is describing. This will help us get the points in the right order so we don't mess up. So B is between C and D means C and D are the ends and B is somewhere between them. I don't know that it's in the middle. I don't know for sure that it's closer to C or whatever without really paying careful attention to the information that came next. So BC equals 10. So between here and here, that's 10. And BD is 3. Oops. I could tell that if I had paid a little more attention to the information that came later in the sentence, that I would have put B much closer to D. So this drawing isn't accurate, but it does have the correct numbers in it. It asks us, what is CD? So from this sketch, do you see how that helps you find the answer for CD? It's 13. Next one, if Q is between R and T. Okay, so what's that describing? It's describing a segment called RT, and Q is the dot that's between them. This time, let's learn from the last one and pay a little more attention to the information that comes later. RT is 24. The whole thing's 24. QR is 6. So where should I put Q if the distance from Q to R is 6? How about closer to the R than to the T? So this whole distance, all the way across, is 24. And just from R to Q, that's 6. Okay, what we're asked is, what's length QT? Do you see how this sketch will help us find from Q to T? 6 plus some length is a total of 24, and so that length has to be 18. Next one, if P is between L and A, so we have a segment called LA. P is the one that comes between them. Okay, if we read a little bit further, I notice that these are algebra expressions. And so that's going to be a little tough just from the expressions to know exactly where to position the dot. Let's just put it somewhere in between. I'm not going to put it exactly in the middle because I don't want to confuse myself and think that I'm making equal pieces or anything. So I'm just going to randomly put the dot somewhere between them and call that P. Okay, now the labeling of the information we're given. PL is x plus 4. So the distance between P and L, label x plus 4. PA is 2x minus 1. So in between P and A, 2x minus 1. And LA, that's the entire length, is the 5x minus 3. So all the way across there, 5x minus 3. Notice how this drawing, taking the time to make this drawing, will help us to answer this question. The segment addition postulate says if we take the two shorter lengths and add them together, that will equal the longer length. Let's come over here on the side and create an equation. So our first shorter length plus the other shorter length is equal to the entire long segment, 5x minus 3. We've created this equation from this sentence. Okay, x plus 2x is 3x. 4 and a minus 1 makes plus 3 when you combine. We could subtract the 3x to the other side, creating 2x there. And since we're putting the letter x on the right, we could add the 3 over to the left side, creating 6. Then divide both sides by 2, and we get 3 is equal to x. You can certainly switch these around if you like. So we have an answer for x, and that's one thing we're asked. X is 3. We're also asked, what is length LA? So LA was the expression 5x minus 3. We now know that that's 3. So 5 times 3 is 15, minus 3 is 12. All of these problems, we used an idea called the segment addition postulate. The other concept for this lesson was the concept of midpoint. The midpoint of a segment is the point on the segment that divides it into two congruent segments. For example, if B is the midpoint of segment AC, then segment AB is congruent to segment BC. The symbol right here, it looks like an equals with an extra little wavy line on top. That symbol is the symbol for is congruent to. It means that two shapes or two figures are exactly the same size and shape. So it's kind of like being equal, but equal is something that numbers can be. Shapes can be congruent to other shapes. So back to what this is describing. It's saying if you have a segment called AC, then point B is the midpoint if this distance is congruent to this distance. So question 6, let's try a problem. Given that M is the midpoint of segment RS, again, if we take the time to draw a quick sketch, it'll help us to visualize what's going on. We have segment RS. We're told M is the midpoint. So exactly in the middle is the M. Now what that definition of midpoint was saying is that if M is exactly in the middle, then this first segment is congruent to the second segment. There's a way to show that. You'll see this a lot in your geometry book this year. There'll be a little mark on there and a little mark on there. And those matching marks mean that those segments are the same length. Okay, if RS equals 10, so RS is the entire segment. If the entire segment is 10, then how much is SM? I think 5. Question B, if RM equals 12, so just from R to M, if that much is 12, then what's MS? From M to S, I think 12. And what's RS, the entire distance? How about 24? Here are some check your understanding questions, so I'll pause for you. Next, you can also use a number line to find the distance between points. Number 11, what is length LM? What is the distance from L to M? So on the number line, we know that L is at -3. We know that M is at 4. We could count the units. That's certainly one way to do it. But if they're really far apart, that's not practical. So let's use the definition of length from algebra class. It's the absolute value of the difference between the coordinates. So -3, can't write here, -3 subtract 4. We can find that absolute value. -3 subtract 4 is -7, and the absolute value is 7 units. Or if we had subtracted the other direction, 4 subtract -3, we would get the same result. 4 subtract -3 is 7, and the absolute value of 7 is also 7. So in algebra, you learned to find the distance between points. You had the distance formula, and that involved finding the absolute value of the difference of their coordinates. The midpoint of a segment is halfway between the endpoints. So if you know the coordinates of the endpoints, you can average them, because averaging something is how you find something halfway between, to find the coordinate of the midpoint. Question 12, what's the coordinate of midpoint M of segment PQ? Well, visually, it looks to be right there. So that's certainly one way you can do it if you have a very accurate drawing and you've got good eyes. But what this is describing is a mathematical way. Average the endpoints. So to average two numbers, you add them together, 8 plus 40, and divide by 2. 8 plus 40 is 48. Divide that by 2, and that's 24. And that's what I thought that the midpoint was anyway. Here are some check your understanding questions. I'll pause the video. We've talked about finding midpoints of segments, and we've also talked about finding lengths of segments, and you'll have problems this year where these ideas are connected. Here's an example. If Q is the midpoint of segment PR, and PQ equals 4x minus 5, and QR equals 11 plus 2x, determine the length of segment PQ. I've drawn that over here on the right. I've drawn segment PR, positioned Q as the midpoint, and because it is the midpoint, I knew that this first segment was congruent to the second segment. And I've labeled them with their algebra expressions. And how this is helpful to me is I now know the relationship of this expression and this expression. I think these are equal to each other. And that's where this equation is coming from. Solve the equation as you learned in algebra class until you have an answer for x. Once you have that answer for x, you can substitute it in your algebra expressions to find whatever segments that you're asked for. And that would help you get those two things figured out. Here are some try these questions. So again, I'll pause the video for you to work on these. There's one more vocabulary word in this lesson because it's connected to the idea of midpoint. The word is bisect. When you bisect a geometric figure, you divide it into two equal, or another word for equal, congruent parts. Number 14, line segment WZ bisects segment XY at point Z. So I've drawn segment XY. I was told that segment WZ bisects it, and so that meant that it touched it exactly in the middle. That's why I know to put this little mark and this little mark. So here is a drawing. What conclusions can we draw? Well, we could say that point Z is the midpoint. And another thing that we could say is that segment XZ, this first one, is congruent to segment ZY. Another way to say that is to say that their lengths are equal. And here's a check your understanding question, so I'll pause one more time for you to work these. So in this lesson, we talked about the segment addition postulate, the idea that you could add two segments together to equal to a total segment. We also discussed the idea of midpoint, a point that's exactly in the middle of a segment. Along with that, we worked problems that involved finding the midpoint by averaging numbers, and we also tried a few just about finding lengths.